Hi guys, welcome to the video. Well, as you can see from the thumbnail, this video is going to be about how I've converted my CNC router to use a USB interface. And I haven't been using it very much lately, mainly because the foam cutters kept me extremely busy. So this has probably been idle for probably about 2 years. And a lot of things that I used to do on here, I can now do on the 3D printer, which is just sat here. And so I do make a lot of stuff on that now. But I came across something a little while ago that got my interest back in getting the router going. But what I'll do, I'll save that for another video. So in this video, I just want to concentrate on converting this to USB. Now this is the old controller that it used to use on a parallel port interface. And what we're going to be doing is converting it to this little setup here. So I'll show you how we do that. Now, although I'm talking about converting my CNC router, this will apply equally as well to anything that's got the parallel port interface. So it could be a milling machine, a laser cutter, or even a foam cutter as well. So if you've been running the parallel port interface and you've decided that it's now time to change for whatever reason, then this could be the video for you. So what I'll do is I'll just go through the different sections we're going to have a look at, so you can decide if this video is going to be of any interest to you. So I'll just refer to my notes, make sure I've got everything here. So the first thing we're going to do is look at the software. That might seem a back ways to do it, but the reason for that is the software dictates what hardware we can use. So if we're going to use a certain piece of software, we have to use a certain piece of hardware. So we'll have a look at that first and the different options we've got there. Then what we're going to do is I'm going to be looking at USB hardware. So I'll explain the hardware we've got here, which you can see really is we've got an MKS board, some external drivers and some power supplies. And I've got it set up here for testing on the bench. So what we'll do later, we'll go on to the live testing as well. So what we'll do then is we'll go on to look at the firmware we're going to be using with the MKS board and how we install that, an easy way to install that. And then once we've got the firmware installed, we'll get it all rigged up. See, I've got it already rigged up here, and I'll explain how it's set up and then how we can test it to make sure it's all working. So you can see I've got 4 motors set up here, and we'll test them all first to make sure everything's working before we move it over to connect to the live machine. Now I've already done the testing on the live machine just to make sure all this works first of all. Then what we do, once we've got it on the live machine, we'll cover the wiring, how I've wired it up. Then what we'll do is then we'll check the axis direction, so making sure the axis goes the right way when we tell it to go. So if we want it to go positive, it moves positive. And then what we'll do then, we'll then check the calibration. So that means if we tell it to move 10 millimeters, it's going to move 10 millimeters and not 9 or 11. Then what we'll do is we'll cover homing with limit switches. That's something I do get quite a lot of questions on. Not on this so much, but on the foam cutter, and it can cause a little bit of confusion as well. So we'll cover that. So what we'll do then is we'll do a test, make sure it all works, and I'm going to be using a pen holder for that because I haven't got any proper dust extraction here. This doesn't normally live in this. It's normally in my workshop outside, so we'll do that to prove it works okay. And then after that, there's a few other things you can do once you've got it that far, like fine-tuning the acceleration and stuff like that, but I'm not going to cover that in this video because it'll just make it too long. So that's what we're going to cover. If that sounds interesting to you guys, then what we'll do, we'll go on to the next section and have a look at the software. So in this next section, what we're going to be doing is looking at the software. Now, as I said in the introduction, the software tends to dictate what hardware we can use. Now, when I was using this before, I was using LinuxCNC and Mach3 on it. I think Mach3 was the first one I used on it, and then I went over to LinuxCNC. It's proved to be one of the most popular videos on my channel. I think last count it was over 100,000 views. So it has proved very popular, and LinuxCNC does work really well. and I also use Mach3 as well, and Mach3 works really well. Now the only issue you have with LinuxCNC and Mach3 is that originally they were designed to use the parallel port, and I'll put some pictures of the old computers, but this is the parallel port here on the old controller card here. And as you probably realise now, computers aren't made with parallel ports. Probably haven't been made for probably a good, must be getting on for nearly a decade now. So I've got a posting on the website what you can do for Mach3. I think it's called 6 solutions for the obsolete parallel port on Mach3, and that's really popular as well. The reason I've decided to go from the parallel port to USB is because the old computers that I had were taking up a lot of space, and they were starting to show signs of failure as well. When I was powering them on, there's little glitches, and I could get them working again, but I thought, I think it's time to move on now. And I had built my own power supply for the controller. I'll put a picture up to show you. Now, back when I first started, 3D printing hadn't really come out then, and things were still quite expensive, so I built the power supply myself with 2 computer power supplies wired in series, which it worked, but you've got to be a bit careful with that. But it was very bulky, and together with the computers as well, it just took up a lot of space. So, and as these computers were starting to show signs of failure, I thought it's time to move on now. So when I came across something that we'll see in the next video that I can use on the router, it got my interest sparked again to get it working. I thought, well, I've got to get it working as USB. The options you've got, if you want to carry on using LinuxCNC, LinuxCNC will not work with a USB. It's just not designed to work like that. If you want to carry on using LinuxCNC, probably your best bet is to use what they call a Mesa card. I think the Ethernet one's probably the most popular. Now, I haven't used any of them, and so if you are interested in going that route, then your best course is to go on the LinuxCNC forums. Now, Mach3 you can use with a USB. There are some adapters around that you can get that are not too badly priced, and you can use Mach3 still. Mach3 isn't being developed anymore, so it's quite old now, but it's still probably the most popular software, CNC software around. And so I did consider going that route, and I have got a license for Mach3. So it may be something I might try later on if I find this setup doesn't work very well. So I've decided to go down the Arduino route using the MKS board here, which some of you may see on the foam cutter. I'm using this on the foam cutter, not with external drivers, but with onboard drivers, and it works really well on the foam cutter. So basically what we've got here in the MKS board, we've got an Arduino with a ramps board in one unit, and it makes a lot neater setup. So if we look at the ramps board with the Arduino underneath, you know, you can see it's not quite a nice looking setup, and plus there's quite a few prints on Thingiverse where you can print some nice cases for it. So the other thing to bear in mind, guys, Mach3 won't work with Arduino. So you do need a specialised USB adapter, so you can't use this setup with Mach3. It just won't work. So my decision was to go for the MKS board using 24 volts. This is a 24 volt power supply with these external drivers. Now, if you've seen one of my other videos, I did show how you could use these external drivers on a foam cutter if you're going to build a much bigger foam cutter than the one that's on the website. And so I did get all this tested and working. So it is a very similar setup. The things that are different really is the firmware is a bit different, and the way we wire the motors is slightly different as well. So having decided to go and use the Arduino on the MKS board, the next decision is which piece of controller software I'm going to use to control it. Now there are quite a few, because this is based on the GRBL firmware. There's quite a few different pieces of software around that you can use, and probably the most popular one is Universal G-code Sender. A lot of guys use that and are really happy with it, and that's Java based, and so that will run on any computer. The other one that you can use is one called GRBL Panel. The one that I'm going to use is going to be OpenBuilds Control. This is originally an OpenBuilds design, and when I've looked at the different pieces of software, for me personally, I like the look of the OpenBuilds Control software. you know, sort of time will tell whether it's been a good decision or not. But and there are others around as well you can use. So what we'll do now, guys, is we'll go on and have a bit of a more detailed look at the hardware and what you're going to need if you're going to embark on this conversion. So guys, in this next section, what we're going to have a look at is the hardware in a little bit more detail. So we'll just go over it bit by bit. So we're not going to need that anymore. It's a shame really, because they were a good board really, but we'll keep it for posterity. So this is the MKS Gen L board, version 1. Now you could use a version 2 as well. It doesn't really matter which one you use. The firmware that I've got for it will work on both, because we're only using 3-axis. So the way I've done it, and it isn't the only way to do it, you can do this other ways, but because I'm reasonably familiar with this MKS board and the GRBL Mega 5X firmware that we're going to be using, I've decided to stick with this route. So you're going to need an MKS board. Some guys have done this using the ramps board, and you can get some adapters to put on here to connect to external drivers. I think they're available on AliExpress, I think. So what we're going to be doing then, on the MKS board, we've got external driver connectors. So we don't put any internal drivers on. Now, these motors on here are rated about 2.8 amps. And the onboard drivers, you get them, the most they can cover in a burst is about 2 amps. So that they're not going to be enough. So what we've got here, and there's quite a few different drivers you can get. So these are the TB6560. And there are quite a few others that people use. These are rated up to 3 amps, so these are 2.8, so they're absolutely fine. And actually, I don't run them at, I run them at 2.6, and I've run them like that on the foam cutter for years with no problem. They're actually the same. I don't know whether you can see it. The actual chip that's under that heatsink is the same as that one there. So these are and all the settings are exactly the same. So it keeps things fairly straightforward as well. So what we've got one for each motor, and on the Y axis, because we've got 2 motors on here, what I've done here is I've just taken the step and direction signals and the enable signals from the Y, and it just daisy chained onto. So these 2 drivers are receiving exactly the same signals. They then come out to these 2 motors here for the Y, and what we'll do, we'll test, once we load the firmware up, we'll test them. But what we need to happen is we need to one turn opposite the other. Now, as I've got it wired at the moment, they won't, but I'll show you how we get round that. So that's the drivers. Now, as I said, there are quite a few different drivers you can use. If you're going to use much more powerful motors, then, you know, if your motors are rated above 3 amps, then you would need some different drivers for this. But they all tend to follow the same sort of principle, using the step and direction pins. And to power these drivers, what we've got here is a 24-volt power supply. Now, behind here, there's another little 12-volt power supply, but that's for something a little bit different that we'll cover in the next video. Now, if you don't want to use the spindle control coming off the MKS board, I think I'm right, but I'm not 100% certain, but I don't think you actually need to put the 24 volts into the MKS. The USB will be enough just to send the step and direction signals. But you probably need to just test that. I have had it working without having the power in, so I think that's okay. But you know, it's probably best to do a bit more research and just double check on that. But I have wired the 24 volts into the MKS anyway, just to be sure. Yeah, so this power supply here, this is a 24 volt rated at 350 watts. These are the TB6560s, and these motors here, although they look slightly different, are exactly the same rating. So these are 2.8 motors here, and these are what I had on my original foam cutter. So yeah, they come in quite handy. So that's what we're going to need. Oh, and the other thing we're going to need as well is some cooling fans. What we want to do is put some cooling fans. My intention is I'm going to create a top for this, and the cooling fans will sit above there blowing. These are 12 volt cooling fans, but because I've got this little 12 volt power supply around the back, they'll be fine. These will come out of old computers, but they don't get really hot, these, so I think it'll be fine with them. So that's the hardware, guys. So what we'll do is we'll go on to the next section where we'll look at how we can install the firmware on the MKS board, and I'll show you where you can get the firmware from as well. So in this next section, what we're going to look at is installing the firmware onto the MKS board, and then the software I'm going to be using, the OpenBuilds Control. Now the firmware is based on the GRBL Mega 5X, and I'll put a link in for that. So I've just downloaded it, just altered the number of axes to 3, and put in some default settings to work with this OX CNC. Now, when you've got it up and running, you can change them settings and it will save them on the EEPROM, so you don't have to go into the actual code and start making changes there. 3D printers, you tend to have to do that a little bit, but the way the GRBL works is it stores the settings on an EEPROM on the controller, so that makes things a little bit easier. So first thing to do then is we'll get the software. Now, I've already downloaded the software because my internet connection in here isn't very good. But by the time this video comes out, all the links will be there. So at the moment it's showing private, but when this video comes out, this will be on public. So we just download the firmware, and I've already downloaded that. Show it in the folder, and we'll expand that, and then we'll extract it. I'll just call it firmware router. There we go. So if we now go on to firmware router. Now what we're using here is something which we use on the foam cutter as well. It's called Xloader, and this makes it really easy to get the firmware on. A lot of the questions I used to get on the foam cutter was to do with compiling the firmware, and people used to get into all sorts of problems with it. And if you're not used to that thing, it can be quite daunting. So this firmware has already been pre-compiled, and all you have to use is this utility called Xloader. So what we're going to do, we're going to plug the controller in on the USB. Now I have some guys that have problems where they can't see the controller in the USB. So the way to check that is if we go into Device Manager, now you could do this on a Mac as well if you want to get the firmware on. If we go into Ports, and so we've got USB serial CH340. Now if you've got a warning triangle there, there's a good chance that you haven't got this 340 driver on there. And what I'll do is I'll put a link in to, it's the Adafruit site. They do a lot of electronic stuff, and they've got a real good article there on how to install this 340 driver and check it's working properly. So if you find you can't see your MKS board, that's probably the first thing to check. So once we've got that, well, what we could do as well while we're there, let's have a look at it again. It should tell us what port we're on. Yeah, So it says USB serial CH340 driver on COM3. Right, so close that down. So on the X loader, what we do is we fire up X loader, and then we need to check the settings. Right, so for some reason it's picked up COM4, so we'll put COM3 in there. Make sure it says 115200, and make sure you've got the Mega 256 set. Even though this is an MKS board, the Arduino in there is based on the Arduino Mega 2560. And then all we want to do is make sure on the hex file we're picking up the right hex file, which we are there. And all we do is we do upload. There we go, uploading. So there we are, we've got 32524 bytes loaded. So what we need to do now is see if we can connect to the board. Now what I'm going to do, I've already downloaded it. We're going to install the OpenBuilds Control software. Now if we go onto the OpenBuilds site, and I'll put a link in the description, you just go to resources, and then you've got the download here. So you can use this on Windows, Mac or Linux. So we're using the Windows. Now I've already downloaded it. So let me just go to the download section. Downloads. There we are, OpenBuilds Control software there. So we just run that up. Shouldn't take too long. There we go. Go next. Just the usual Windows install. So run the OpenBuilds Control. Allow access, yeah. So it's a pretty standard Windows install, just follow the instructions. And what it does, it puts it down into the taskbar there. So we just click on it there. Starting OpenBuilds Control. The beauty of this, guys, you can also connect to it over an IP connection as well. So you could leave this running in one room and run it in another. So it's actually found the port. Quite interestingly, on the MKS board, it calls it a fake. So if we do a connect, we should see it connect, and we should get all the settings there. So it says at the bottom there, firmware detected, GRBL version 1.1 T on COM4. So if we go to, and if we click on the settings, we can see all the settings we've got. So these are all the settings that have been pre-compiled into the firmware. Now, if you've used it before if you've done this before, it will retain the old settings in the EEPROM. It will bring up the old settings, but if it's a brand new setup, it should have the default settings in there. That's the firmware installed, and if we just press unlock, then we can start moving some axis. But we'll go into that into the next section, where I'll show you how it's been wired up. So we've got the firmware installed on the MKS board. We've got the software installed on a computer. And again, if you don't want to use OpenBuilds Control, there's quite a few other pieces of software around. But actually, I think this is quite good software, and it makes setting up and troubleshooting quite easy as well. So I'm quite impressed with it. But time will tell. And if you prefer to use something else, then but by all means do that if you're more used to something else. So what we'll do on the next section, I'll go in to show you how I've wired these stepper drivers up to get these motors working, and so we can get the two Y motors working, one turning opposite to the other. Right, so in this next section, what we're going to do is have a look at how I've wired the MKS board up to the drivers, the settings on the drivers, And then what we'll actually do then, we'll actually test to make sure that these test motors all work. Now, as I said earlier, on the OX machine, we've got 2 motors on the y-axis. So that's why we've got 2 drivers here. Now, I have seen some guys where they've just used 1 driver and just paired up the motors. Now, that can be a little bit dangerous, because what you're expecting the 1 driver to do is to supply current to both motors. So, you know, it's better to do it like this, 1 driver for each axis. So the way it's wired, and I'll put a diagram up to show this, because it's not going to be easy to see down here. But basically what we've got on the, let's make sure we've got the right, yeah. So coming in on that side, let's get you zoomed in a bit. So what we've got coming in on that side is the signals from the MKS, and then on this side we've got the signals going to the motor and also the power. So that's what you can see here. So we've got the power down on these red and black wires here, and then the stepper motors are coming in on these motors here. So what we've got here on the MKS board, we've got external connectors there, and this is where our connectors go on. Now what I've done is I've bought some connectors that you normally use on for NEMA 17s, and I've just cut the ends off, and then I've then wired them onto the connections using these ferrule connectors. I'll put a link up to that. I'll show you what I've used for that as well in the picture. And so what we've done here on these 2 here, basically all that's happened is the direction signal for the y-axis is going to both of these drivers. The step signal is going to both of these drivers from the y-axis, and the enable signal is going to both of these drivers. So when you see them working, you'll see both of these lights flash simultaneously. And so what happens then is we then get the signals coming out exactly the same. On these drivers, we need to set the dip switches, and I'll put a diagram up of the settings I've used. But basically what we're doing on here, they're set to 2.6 amps, and we're set to 1/8 microstepping, which is for a CNC router is more than enough. 3D printers, you tend to go down a bit more to 1/16, but 1/8 microstepping is absolutely fine for this CNC router. And then there's some other settings which I'll put up, and there's the settings I used on my foam cutter, and they worked all right, so I've just basically copied them. I think one of them was to do with decay, and I forget what the other one is, but I'll put a picture up and show you what the settings are and what I've used. And those settings I've used when I was using the foam cutter, and when this was running Mach3 and LinuxCNC. I used to be able to run Mach3 and LinuxCNC off of this, and all I used to do on the computer was swap the disk out to a different disks. I think I showed that on my LinuxCNC video. Mach3 can look a little bit daunting, so I just used to have a setup where I just used to be able to swap the disk out very quickly. But anyway, I digress. Right, so we've got all them set up, we've got it wired up, so we'll plug back in, and then we'll put some power. So when you first power up, a good indication is that these motors should be locked, and if I try and turn them there, you can feel that they're not turning, they're all locked. So that's a good indication. If you can spin them very easily, it's usually an indication you might have your pairings wrong, or something's not right in the setup. So what we can do as a quick test, I mean, because we've not got this connected to anything, we should find they just work straight off. So we'll connect. So we're connected there, and we've got the connect there. We haven't got any unlock or anything. So what should happen now, if I just jog, if I press X, I think this is our X, I think that one should spin for us. Oh no, this one's our X. There we go. If I just hold it, and on the OpenBuilds Control we can alter the amount. So if I do 100, there we go. So if we try the Y, now what you'll see on the Y, and the reason I put these little pointers on, let's put them both so they're pointing the same way, more or less. There we go. What you'll find is they'll both go the same direction, which isn't what we want for this. So in a minute I'll show you how we change that. And then on the Z axis, there's our Z. That's going quite quick, so I've told it 100 millimeters, which is on this Z axis. I haven't got 100 millimeters travel. Put that back to 10, and then we'll go. So all the axes are working okay, apart from we need to reverse one of these. Now it doesn't matter which one we reverse, because when we get onto the machine, when we check the axis direction, it'll either go one way or the other, and we can change that within the software quite easily. So the way to change the axis, and what I'm going to do, I'm just going to disconnect and power down. Always do everything, these guys, with the power off. You don't want to risk any damage. So the way we get one of these going the opposite way, all we have to do is swap one of the pairs of wires around. Now some guys say you have to swap them all over, but I found that I just swap the pair here. So what I'm going to do on this one here, I'm just going to swap the red and blue, swap them around, and we should find that this motor then goes the opposite direction to that motor. So we're powered off. There we go. So we'll connect back. There we go. So fingers crossed, if we turn the Y now, we should find, so let's do it 100 millimeters so it goes a bit quicker. We should find that these motors go opposite to one another. Yeah, and there we are. And if we do Y, so that's our Y axis, which is what we need for the Y axis on the OX machine. And so that's working absolutely fine like that. So we've got everything bench tested. We know it all works. We can't test the homing or anything yet until we get it on the machine, but we'll cover that. So that's the bench test done. Now, problems you might get, and I do get a few calls about this, is that some guys say their motors make a funny noise or a juddering sound. Generally, it's normally you haven't got the pairs connected properly, and there's an easy way to check. So there's an easy way to check on the motors if you've got the pairs right. Now on this little motor here I've just got for demo purposes, we've got the 4 wires on. And if you just hold 2 of the wires together, so I've got the yellow and green here together, and if you try and, you can see that spins, I'll show that spins very easily with them linked. So if I now try a different wire, so I've got the green, and if you see now, you might be able to hear it if I get it close to the mic, you can hear it, it's a lot harder to turn, and what it's doing, it's generating a magnetic field in there. So so for this particular motor, the red and the green are a pair, and if I just try the yellow and blue, just put them together, should get the same. Yeah, if you can hear it, we've got the same again. So that's a good way to check you got the pairs. So they're probably the only problems you're likely to get bench testing. So once you've got the firmware installed, you've got it wired up correctly. So do check your drivers, guys, because the wiring I've showed you here is for these drivers, and I know some of the other guys have used different drivers. You don't always need to use the enable pin. So do check your documentation with your drivers, but the basic wiring that I've shown you here, well, should work fine. So what we'll do into the next section, I'll get this all connected up and we'll do some testing on the live machine then. So in this next section on wiring, guys, I'm going to show you how I connected it up to my OX CNC router. Now, as you can probably see, I've used a lot of LAN cables. So these are 24 gauge LAN cables, and what I've done is, because there's 8 wires and we need 4 connections here, I've just paired 2 together. So we've actually got double the current capacity on there. Now, the capacity for these is fine for these motors. These motors are rated at 2.8 amps. We've got the driver set at 2.6, and unless they're working really hard, they probably won't really be pulling anything like that. So it works fine, and I use this setup on my old foam cutter using Mach3 and LinuxCNC, and it works absolutely fine. But that was on my old driver board, which if you remember we saw in the first section. So, and all the settings are exactly the same. It's all done on dip switches here, and these are all the driver chips on here. So this is the old parallel port board, which worked really well. A bit of a shame to get rid of it, but time marches on. So what I've also done is I've wired the limit switches in as well. When we get onto that section, I'll show you how we check them. So all we've got is just a simple junction box there, and we're going into the sockets on the MKS board. I'll put a diagram up to show you that as well, how that's wired in. And then when we get onto the section on that, I'll show you how we test them. But the actual limit switches themselves, I've got one mounted here. I actually fabricated this bracket with a 3D printer because one of the problems with the old OX, this machine is no longer made. They've gone on to one called the Work Bee now. And one of the issues with it was getting the Z limit switch in, and I did originally have it under here. I mean, you can't see it's right under up here, and you know, it was just difficult to get set up and adjusted. So I spent some time making this bracket here, and it's triggered by this small piece of little aluminium here, and it works really well. As you can see, the X limit switch is over there, and the Y limit switch is down the side there on another bracket. I'll put a picture in to show you that because you can't see it the way what it's set up here. Now, as you can see, I haven't got a great deal of space here, and I've actually got the laptop on the end. When I was doing some of my testing, I got something wrong, and this gantry careered up that way and pushed the laptop off. I had to sort of grab it out of the way quick. It was a bit of a panic. So hopefully that won't happen you know, when we go into the next section. So that's basically how I've set it up. So what we'll do, we'll go on to the next section now. So the next section is going to be, what we're going to do is we're going to check to make sure each one of these axes works in the correct direction. So before you go any further, so although we've tested it on the bench with our 4 motors, we don't know which way it's going to turn when it's actually on the machine. So that's the first thing we need to do is test the direction. I'll show you how to do that, and it's quite easy to change as well if it's wrong. So we'll see in the next section. Right then, so in this next section what we're going to do is make sure that these axes go in the right direction. So we've tested it on the bench and we know that our motors work correctly, and we've made sure that the Y motors turn opposite to each other. But what we need to do is make sure that the axis goes in the right direction. So on this machine, the 0 point is over in this corner. So when we go X in the positive direction, it needs to move this way, and then we go X in the negative, it needs to go back. And for the Y, it needs to move forward this way in the positive direction, and then that way for the negative direction. So, and then on the Z axis or Z axis, the convention is when it's right up the top, that is that's going positive, and then as it goes down, that's going negative. Now what we need to do before we do any of this, we need to move the axis into the middle. So as you can see here, I've got the X right in the middle, I've got the Y a little bit off the stops here, and the Z axis is a little bit, so there's the limit switch there. Now the reason for that is if you go and move it and it goes the wrong direction, you're not hard up against the stops already, and, you know, put load on the motors. It probably wouldn't help them. So we'll just move these out of the way for now. So what we're going to do, first of all, we'll switch some power on. Right, so we've got power on. We're not connected at the moment, so we'll connect to the board. So it's saying COM6, Arduino fake. So there we are connected. Now what you want to do first of all, it's a good idea to disable homing. So if we go onto the GRBL settings, if we just go down to $22, I think, and we've got homing cycle enable, we'll just disable that while we're checking the direction. So we'll just disable that. I'll say yes to that. And there we go, and you can tell that's working now because we've got the homing button there. It's greyed out, so we can't use it. So the next thing we need to do, now that we've got each axis in its middle position, on the OpenBuilds controller here, set the, oh, I have to unlock first. We set the jog distance to incremental and 1mm. What we don't want to do is do it 10mm because we haven't checked the axis calibration yet, and what could happen as it goes, as it moves off, if we haven't got the calibration right, even though we've told it to move 1mm, if the calibration is not right, it could be moving 10mm, and if we've got it set on 10 already, that would be 100, and you know, before we know it, it's careered off. So what we want to do then is check each axis. So I'm going to click on the X plus, and what should happen, it should come over towards me. So we do X plus, yeah. And if you see it's going okay, then what you can do then, just to further test, you can put it at 10mm then and do 10. So that works okay. So if we try it, so the X axis is correct, and we just check the other axis as well. We'll go back down to 1. And so Y plus, it should come forward, which it is doing. If we do that to 10, and then, so that's working the correct direction. So what we'll do in a minute, I'll show you what to do if it's going the wrong way. Now on the Z or Z axis, what you want to do, I suggest you use 1mm, because there isn't as much travel on here. I think I've only got about 50mm travel on mine, and it's quite close to the bottom, so we don't want to be sending it 10. So what I'll do is if I do Z or Z plus, it should go up. There, I can see it's going up, and if I do, so we now know all our axes are working correctly. Now if you find one of them is working the wrong way, all we need to do is on the OpenBuilds is come to the settings and go down to $3, and it's got a nice little toggle switch there. You can just reverse whichever one's going the wrong way, and that works really well. So that's dead easy to do like that. You can do it just by putting the actual value in. Some of the other softwares might not be as simple to do, but this is really good for that. So we now know that our axes are working in the correct direction. So what we'll do in the next section, we'll go on to look at the calibration. Right, so now we've got the axis working in the correct direction. What we need to do now is check the calibration. Now, what we mean by that is that when it gets a G-code to say move an inch or 20mm, it actually moves that distance. So on the OpenBuilds Control software, they've made it quite easy. So if you go down to $100, and we've got calculate steps here, you can see it's already got a figure in there already. But if we go to calculate steps, and it brings up a pop out, and it's got some fairly standard setups in there. So on the OX CNC, the X and Y are belt driven, and it's using these GT3 belts, which are these. I'll just pull a bit out here, you can see it. This is the GT3 3 belt. And the pulley that it uses the pulleys that are in here and in here. I don't think you can see them too well, but they're 20 teeth. And we're using, the motor type is 200 sweats per revolution. We're running 1/8 microstepping. So that gives us our figure. Now if you're using something different, you go there into lead screw or different belts, put all your settings in, and it applies them settings. So we just cancel that one. If we go onto the Z. So on the Z, what we would do is say lead screw. So this is actually an 8mm lead screw with 4 starts. It's using 1/8 microstepping, 200 steps per revolution. That gives us our value. So if we say apply, so that's how we get our value. So those are standard sort of values that you can put in. And what we need to do now is, once we've done that, we need to actually check it. So let's go back to control. And the way to check it, and the way I do it, I use this rule here. And what I do is I line it up onto a, so let's go onto 100 there. And then we'll just bring the Z down a little bit. We'll go on to, and what I've got in here, I've got a V-carve bit, so that's a lot easier to see there. So if we turn it that way, and then what we want to do then is tell it to move 100mm. So the way to do that, let me just move this out of the way a little bit. So I'm going to 0 the y-axis, and I'm going to tell it to go G 0 Y 100. And what we should find is we should have exactly on the 200. So we send that command. So that's with my old eyes, that looks as near damn it to me. So that's right on the 200. Now what we'll do is we'll go back. Now it's a good idea if you can do this over a much longer distance. So like this machine here, it'd probably be a good idea for me to say start it right up here and go right down the bottom to get it. So the bigger the distance, the more accurate you're going to get it. Right, now if for some reason you found that was wrong, what you can do on the OpenBuilds software, if you go up to Wizards and Tools, so if we found that our y-axis wasn't going as far as we so if we found our y-axis wasn't ending up exactly on 200, what we can do is we can go into calibrate y-axis steps per millimeter, and the way this works is what you do, you make a mark. So we've got our mark there, and then it says I've made my first mark. And then you tell it to move 100mm like it says there. So this is going a little bit slower. And that's spot on, but if for some reason it hasn't, so I've made my second mark, then what you do then is you put in the actual distance it did move. So say for example it only moved 99. So what it's telling us now, it's 26.94 instead of 26.667, and then you apply that, and that would put your setting in. I'm not going to do that because this is correct as it is. So what you could do that for each axis to get it calibrated absolutely right. Now you could do this to start with anyway if you wanted to, rather than going through the calculate option. But so either way, you should get your machine running fairly accurately. So that's calibrating the axis. So what we'll do in the next section, we'll go on to have a look at homing and how we set that up. Right guys, so now we're coming to this next section. This is a section that I do get quite a lot of calls for with the foam cutter as well. There's a few settings to set on it which, if you've not done this type of thing before, can be a little bit confusing. There's a couple of ways to do homing on the CNC machines. You can have a switch at each end of the axis. So if you have a look here, I've got a switch on the x-axis here at what's called the x-min, but I haven't got one up here, and I've done the same on the y-axis. Well, I've just got a y switch there, and there isn't one up the other end. On my old setup I did have that, and to be honest it causes more problems than it's worth. And you only have one on the z-axis anyway. So what we do is we set up soft limits. So what happens if it comes up to here and we've told it how the maximum it can go, it'll just stop. And I think we can demonstrate that as well later. Now on the MKS board here, I've got the X-mins wired in. I've got them wired into this junction box here, and these are the two cables for switches. Now what we need to do is we need to check that them switches are working, and the way I've done this setup, I've used normally open switches. On the foam cutter I use normally closed, but for some reason I couldn't get it to work very well using normally closed on this, so I went back to what's the defaults for this. So what we do, we go into troubleshooting, and we've got our switches there. So this is my X limit switch here. So if you just press that switch, what you should see is the status comes on, and then the same. So if we do the Z limit switch there, that should come on. And if I do and then to what? So before you do anything, you need to make sure that's working. So if you don't get it working, you're not going to get anywhere. Then what we need to do then, we go into settings, and we go down to where are we? Here we go, $. Yeah. So at the moment I've got soft limits enabled, disabled, and homing cycle enabled. So what we need to do is at the top there, toggle that switch there, and that puts our limit switches on. And if we come down to soft limits isn't enabled, hard limits is enabled, and the homing cycle is enabled. What we need to do is, I think they do tell you need to save the settings first before you enable soft limits. So we do yes. There we go. We go back down, and then if we go to soft limits now and enable soft limits, and if we go further down, right down to $130, $131 and $132, that's our distances. So these are the distances we set in the software, so it knows how far to send the axis. So if you have a look on my x-axis, from the home position over to about here, as close as I can get, is about 315 millimeters. On my y-axis I've got 500, but I think I can go slightly further than that, about 520. And then on the z-axis I've only got about 50mm here. So what we want to do first of all, we'll save these settings again. If we come back to control, there we go. And you can see now that the homing switch is enabled. So what we want to do, if we click home, we should find all this lot homes. And if it homes in the wrong direction, I'll show you what we need to do on that. So it does the Z-axis first. I see it finds it, and then it goes back and does a slow move. And you can see it's doing the X and the Y together. There we are, we're home now on the X and Y. So there we are, we're all home now. So what we would do now is, if we know we've got a workpiece over here somewhere, we would bring it over to here now, and then set the 0. And if for some reason we had a power cut or something, we could rehome the machine and then bring it back to this no starting point, and it should start off in the same place again. Right. Now, if for some reason it goes wrong, so let me go back onto settings. If you find it goes the wrong direction, we've got a home in invert mask in here, I think so. There we go. So on $23, there's a setting called home in direction invert, and all we would need to do is go into that. We click into it. And all you need to do is see which one's going the wrong way, and then click on the appropriate. So I think the black circles means it's inverted. So you can see on mine I've got the X and Y inverted. Now if you find, as soon as you set home and going, and it goes the wrong direction, just press the abort command quickly, then go into your settings and change it to whichever axis is going wrong. Now there are a couple of other settings you might want to set as well. So on $27, that's the pull off distance, and I've got mine set to 5mm. So what that does, once it's homed, it pulls it just a little bit further away from the switch. So what you can find can happen, if it homes and you haven't got that distance, it'll just keep bouncing on the switch, and you'll get sort of false triggers. So it's always a good idea just to pull it off slightly. Another setting that you might need to play as well is what's called debounce, $26. I had this in my very early days with Mach3. I had some problems with it homing. So Mach3's got a similar setting that you can set. To start with, I didn't know what it was, and I put a posting up on a group, a CNC group, and a very knowledgeable guy came back to me and said, just increase your debounce. Increase the debounce, and it worked perfectly, you know, for several years after that. So basically that's homing, and this is how I've set mine up. Now if you want to set it up with 2 switches on each axis, and that's absolutely fine. You know, you've just got a bit more wiring to do, and from my personal experience, I found that, you know, the more wires you have, the more likelihood is there things to go wrong. And I did find that on the old machine as well. I did have a couple of wire breakages, not through use, more through moving things around and catching the wires. So and then it can take some time to find as well. So that's homing, guys. So what we'll do now is, now we've gone on to, we've checked the axis direction, we've checked the calibration, we've checked homing. I suppose the next thing to do is run the test and see what it goes like. So guys, now we've got it all checked and all working properly, what we're going to do now is run the test, do a test cut just to see if it works as we expected. Now as you can see, I've got the router on here. I think this is a Makita clone. It was actually quite cheap and it works really well. I've never had any problems with it, but I haven't got any proper dust extraction in this room here, so I don't want to run the router. So what I'm going to do and I found this on Thingiverse, is a pen holder. And it's built to fit on the bracket there. So what I'll do is I'll quickly swap that over. Now what I'm going to do to test this, I'm going to use the OpenBuilds CAM software. So if we go on to, I've got a link for this. This is actually runs on the web, and I'll put links in the description for this. I've not got particularly good internet connection in here, so it's probably a little bit slow. So just to recover last workspace. So what I've done here, I've just created some text. Once you create the text, you then add it, and that's what it's got here. And these are the different operations. And if you go into settings, I've told it the end mill diameter's 1mm, which is probably about right for that pen. And then I've told it to just go down 0.25 of a millimeter. So all we do, get some paper. Right, so what I'm going to do, put the paper down. Right, then what I'm going to do is take the pen lid off, and come back to the control software. I'm going to 0 the X, and then what we're going to do with another piece of paper, so I think I'm going to go down 10 because it's up a fair way. Could risk another, I think. Right, so I'll go to millimeters now. We're getting close, so what we'll do, so I'm just looking to see if it's touching, we'll go to a point. There we go. Just touch in there, and then we'll 0 that. So guys, that brings us to the end of the video. So I hope that's been useful to you if you've been thinking about doing the conversion. And as I've said, it's not the only way to do conversion. Some guys actually connect the an Arduino up to the old parallel port, and that's another way you can do it, but I didn't want to cover that in this video because it would just make it too long, and it's something I wouldn't embark on doing anyway. That's basically how I've converted my CNC router, and as I said in the next video, we'll be putting something else on there to embark on something else I've been looking at recently. So thanks very much for watching. I hope you've enjoyed it. Any questions, just drop me a line either via the website or in the comments, and I will have a posting on the website with all the details as well, and all the links you need for the which I've mentioned in the video. So thanks for watching, guys, and I'll catch you in the next one.